Hello everyone, thanks for coming, and today we are going to do a review of what we have learned in week 3's lectures. So basically, we introduce some concepts of data structure in discrete mathematics. First, we introduce list. A list is an ordered sequence of objects. So order matters, and list always consists of finite many elements. Elements may be repeated, and the length of a list is the number of elements in it. It is always finite. A list of length 0 is the empty list denoted by the two parentheses. Then we learned the concept of factorials. So the factorial, the parenthesis of n with a subindex k is the number of ways to choose k objects from n objects without repetition. So with repetition, the number of choices is n to the power k. So basically, we use the factorial to denote how many lists we can construct. We have a very special notation if k equals to n. So that is n times n minus 1 times n minus 2 to 1. Then we introduce the concept of sets. A set is a repetition-free, unordered collection of objects. So we don't allow for repetition, and all the elements in a set are unordered. The order of elements does not matter. For instance, the set of 1, 2 is equal to the set of 2, 1. There can be both finite and infinite sets. For infinite sets, we have countable infinite sets like the set of natural numbers. We also have uncountable sets like the real line. So for sets, we use cardinality. For finite sets, the cardinality is the number of elements in a set. For infinite, the cardinality is countable infinite or uncountable infinite. We introduce subsets and how to prove a set is a subset of another. We use a notation A is a subset of B, provided that both A and B are sets and B contains the elements A has. So it's different from the notation belongs to. We say that X belongs to A if X is an element contained in A. It's different from A is a subset of B, because here the object X is an element. Then we define the power set 2 to the power A, where A is a set. So it is the set containing all subsets of A. So if A is a finite set, the cardinality of the power set 2 to the power A is 2 to the power of the cardinality of A. We then introduce some basic set operations like the union A union B. It is a new set containing all the elements that is either containing A or containing B. We have the intersection set A intersects B, so its elements are the elements that are contained in both A and B, the difference A minus B. So its elements are the elements that are contained in A but not in B, the symmetric difference. A delta B is A minus B union B minus A, the Cartesian product A times B. So its element is the list X and Y, where X is in A and Y is in B. We have some properties of union and intersections. To be more specific, we have the theorem. If we denote A, B, and C to be sets, the following rules are true. The commutative rule, A union B is B union A. A intersects B is B intersects A. The associative rule, A union B union C is A union B union C. A intersects B intersects C is A intersects B intersects C. The union of A and the empty set is A. The intersection of A and the empty set is the empty set. We also have the distributive law. A union B intersects C is A union B intersects A union C. A intersects B union C is A intersects B union A intersects C. Finally, we have the De Morgan's law. So it's different from the plus and the multiplication sign. It's more like the Boolean algebra we introduced last week. That's the summary for what we have learned for this week. Thank you.